Hello everyone. Thank you for attending today's Trailhead live session on integrating external data into Lightning Web Components. My name is Stephan Chander-Garcia and I'm a Senior Developer Evangelist here at Salesforce. If you wanted to reach out during today's session, I will be available in the chat window, or you can find me on Twitter at StephanWCG or via email at stephan.garcia@salesforce.com if you have any questions or follow-up about today's session. Now, before we get kicked off with the content, I of course have to point out our forward-looking statement. Please make any purchasing or investment decisions based on our currently available technology and not any future features or functionality that we might be talking about today. Now, before we get into our content, just a quick run through of what we're going to be going through. Initially, I want to talk about defining a use case and digging into your Salesforce org and finding a way that you can benefit from bringing in external data through Lightning Web Components. We're then going to go through the process of designing a component and really looking at where the data is coming from, how our UI will react to that external data, and how we compose that component all together on a page. We're then going to go through and build the component and get hands-on. Lastly, we're going to take a look at how we can take that component that we built and enhance it with some common design patterns that can help you create familiarity for your users around the components that you've written. And then we're going to go through a recap and see how it was all done. So let's talk about defining a use case. It's really important that when you're going to go out and put time and effort into building a component from scratch, to make sure that your users are going to be finding benefit from that work. And so as we do that, I want to take a look at the sample gallery just for some inspiration. It's a great place to go and look at some sample apps that have been created by the developer relations team and maintained by them that give you the ability to interact with the component, see the code, and see how the app all really comes together. Now, we're going to use Dreamhouse today, an app that I'm sure you're familiar with if you've seen any of our keynotes in the last few years. And in order to do that, I'm just going to go over to the GitHub repo, and you can run through the instructions for installing the app, and it will deploy the source into one of your Scratch orgs. Now, I've already taken the time to do that today so we can get hands-on a bit quicker. And this is what Dreamhouse looks like when you open it up in your org for the first time. You're navigated to the Dreamhouse app, and you can go ahead and explore the different tabs and components that we have available for you to view. Now, today we're going to take a look at the Property Finder. You'll see the Property Finder has loads of Lightning Web Components here that you can use as inspiration for creating your own. You can see here we can search through properties, we can view the map, and we can select properties and see those properties. Same thing with the Property Explorer. We can see here we have some search filters that are applied. We have these great tiles that provide a really rich experience for our users. And when we select on a property, it will give us a bit more detail and allow us to navigate to that property. Now, when we're on the property page, you can see here we just have our basic property details. We have some details about the broker. We have this nice little chart showing how long the property's been on the market and a map. And all this is brought to life using those components. Now, how could we use external data in this scenario to bring even more power to this property page? Well, having been looking on the market myself recently, one of the statistics that we'll see when looking at properties is the ranking of the schools nearby, or what available courses there are to your property. Now, there are many external data sources that we can use to go out and grab and identify what the nearby schools are and what their rankings are to a property. So it gives us a great use case. You'll see within our property page, we already have that location's latitude and longitude here, so we can use that maybe to help us out a bit later when designing our component. So let's take that use case. Let's see if we can build a Lightning Web component that will allow us to display nearby schools to this property. I think that gives us a use case that's beneficial to our users and could immediately provide value and impact when they start using the new component in the context of a property. Now, let's talk about the design process. We have our use case. How are we actually going to build this thing in the next hour-ish? So first, let's talk about designing our component. We're going to start out with the data. Where's our data coming from? What is the data source? And how can we use that information in the component? We're then going to take a look at the user interface and how we can identify common design patterns that we're already using in our other components and bring them into this Property Explorer component. We're then going to prototype that and identify what works, what doesn't work, and take that prototype and maybe use it later to sketch out our component. We're then going to understand how our component lives in a page and what context it needs to run We already mentioned that we have that latitude and longitude field on the property, so how can we bring those into our component? And then lastly, we're going to talk about putting these three components together and compose them inside of our component so that the interactions are timed properly and the data gets to our component's hydrated, and our users can gain value and benefit from that component. Now, starting out with the data, I did a little bit of pre-work and research before today's session to find a data source that I thought would be suitable for the Dreamhouse app. And what I came across was the Code.org local schools database. Code.org is a nonprofit that provides directory services and sort of upskilling help on training you to code, whether you're a student in high school, whatever. And they give you a tool and a database that you can use to search for that information. Now, if we take a look at what that looks like, this is the Code.org local schools database API, and it provides you the backend data to their local school search engine. Now, if we click on that database, you can see here we've got some great information here. It's just in a JSON format. Let me go ahead and zoom in and take a look at this a bit better. And we can see here we have things like the name of the school, the website, what levels they have, and quite interestingly, what languages that school teaches. And as you keep looking through this, you can see there's some great information there that we can use to find out more information about the schools and what might be nearby our properties. Now, this is great, but it's just a really long file with loads of information about different schools. It doesn't give us any context to the distance from our current location, and it doesn't do any of the searching. And that's what Code.org have put this there for. They've put this to give you inspiration to create your own search engine and to use this as a template for learning how to write against an API, which was a great opportunity for us as well to go through and look at how we could do that to interact with Dreamhouse. Now, the challenge we have is that this file is too large for Apex. We can't pull this file in and then parse it and then look for the nearby schools to a location because of its size. So we'd have to build an API on an external service or a third-party service to expose this data. So what I did was build a quick API in Go, because Go is a great language for just writing an API, getting it out there in the open. And that's made even easier with the Heroku build pack for Go, because we could write our API, make it searchable by geolocation, and deploy it in a couple of hours. And on top of that, I've made all the code available on GitHub so that you can go ahead and try that out and expose this API for yourself. Now, if we take a look at what that looks like, you can see here we have our GitHub repo here with our Go API. All of the main code is in the main.go file. You can go ahead and explore that. You can see which modules we're using to create this API. For example, you can see here we're using a router to grab the latitude and longitude from the URL. We're going through finding the distance from that latitude and longitude, and then we're going to be returning those top 3 nearby schools in our response to this API. Now, if you want to dig into detail, feel free, go check out this repo, clone it, or you can use the deploy to Heroku button to deploy it directly to Heroku and take advantage of that right from your environment and create your own version of this API. Now, once we have our API up and running, the response body looks exactly like the response that we were just seeing in that JSON file in the browser. We have the name of our schools. I think that's something we can take advantage of. We have a website. Maybe we can navigate to that website, push the user in that direction. We have which levels they teach, so elementary school, middle school, or high school. We then have their languages, and I think this is really cool. I think we can do something quite interesting in our Lightning Web component to showcase what languages the schools offer. And I think because we're writing a component for Dreamhouse, which is set in Boston, I think it's quite relevant to see that the main focus for anyone buying a house might be any of the computer science schools or courses that are nearby. So I think that gives us something to work with from a data perspective. So now let's take a look at the UI and how we can start developing and designing what that's going to look and feel like. Now, number one place to start is the Lightning Design System. Memorize it, know it, visit the website constantly, because the closer you are to the patterns and to the designs, the easier it is for you to quickly build components. Now, I love using Sketch. It's a great tool for wireframing and prototyping, and allows you to really create user interfaces that you can then share and distribute paper prototypes with your end users to really get some feedback and ensure that what you're building is correct. Recently, we've launched the Sketch UI Toolkit, and really enhanced it from its original version so that we can get all of those Lightning Design System patterns, components, fonts, everything you need in Sketch for us to use and create our components. And then lastly, try and relate those to base components, because the more base components we're using, the less markup we're having to write ourselves, and it creates a nice consistency around all of the components that you're writing and ensures that your components fit really well into all of the standard Salesforce components and pages that they're going to be interacting with. Now, I've already gone ahead and identified some of the key components that we can use to build out our School Finder component. You can see here we have a card that our component will live in. I think it's a good pattern to use. Almost everything within Salesforce is nested within a card, and it's a great starting point. We then have tiles, and I think a tile is a great way to display information. You see, if we go back to our data, we have things like the name, we have the website, we have the description, we have those skills. I think that that's a great way to include lots of information and show multiple tiles inside of our card to give us a really good idea of what schools are nearby. And lastly, we have the badges. And I mentioned earlier that I thought the languages were a pretty cool feature of the database. I think it'd be great if we could show those languages in a badge inside of the tile so that we can sort of get a really nice experience for the user and give them a component that looks nice for them to use. Now, I'd like to actually jump into Sketch and show you what it's like to design that component within Sketch before we go and write any code. So we're going to go ahead and start out by pressing the Insert button up here. Once you do that and you've imported all of the design system libraries from GitHub, you can see here we're given all of the Lightning Design System patterns, charts, components to work with. Now, I'd actually like to start out with the artboards, and in the artboards we get a template for what a page might look like within Salesforce, and I'm going to go ahead and bring the large desktop page into my canvas here. And you can see here we just have a nice placeholder for our page. We can then go into the wireframing tools and we can bring in a lot more components that sort of mimic what might be on the page surrounding it. For example, I always like to bring in a page header for a record because it makes me feel like my component is living in that record context as I'm designing it. And we're going to go ahead and shrink this just a little bit so that we have a nice uniform experience with our header there. Now, as we mentioned in the slides below, we want to start with a card. And so let's go ahead and go to our components here. And you can see here we have our Lightning Design System components for web. And you can see all of the components that are included in the patterns within the Design System website are available here. And so we can go ahead and start out with a card. I'm going to go ahead and select this card and drag it onto my page. I like the idea of this component sitting in the right-hand panel of a two-panel page layout. And so we're going to go ahead and just give this some space and stretch this out and design our component. So let's go ahead and zoom in on our card here. You can see here it has a title, it has an icon, so we can go ahead and update those. So let's call it Local Computer Science Schools. Okay, and we can go ahead and select the icon, and it will give you the list of all of the standard and custom icons available for insertion into the slot. And so let's go ahead and select the standard icons. And because we're looking at computer science schools, I'm going to go ahead and select Apex here and give us that nice cool icon in our card. So the next step is to create a tile. So a tile isn't necessarily a standard component that exists within Sketch, but more of a pattern that you can reuse around your components. And so to create my own tile, I'm just going to start out by inserting a shape here into Sketch. And I can go ahead and draw that shape onto my card here. And you see we've got a nice rectangle that's been created. I can go ahead and update some of the style of this. We're going to go ahead and set that there. Okay. We can open up the style here. We can remove that background color. We're going to leave the border color the same. I know the one in the design system is a little bit lighter, but we'll worry about that when we're writing our component. So now let's go ahead and bring in some of that text as part of the tile. You can see here in all of our components, we're able to see all of the different styles available. We can see the different body styles and variants. So for the top, I'm going to go ahead and put in the name of the component here as a link. Okay. And on the top of here, we're going to go ahead and call that our code school. We'll call it Code Camp, this one. Okay, and that gives us that name from our data set. And now let's bring in a body text font and size here. And so we'll go ahead and grab just the standard body text. We'll drop that right below there. And we can say, okay, what is the distance? What is the distance from our current property that we're viewing to the code school? And we can just say it's 0.01 miles. Let's take a look at the description. We can go ahead and say this is a description. What's another field in the data set that we really like that I think would be beneficial to the users? I think identifying what level of the school is, so we can sort of get an idea of the age ranges available. And so we can say level, and we can say elementary. And lastly, we have those skills. And like I said earlier, I thought the skills would be a great thing to do as a badge. And so let's go ahead and go into our component for web here. And here you can see we have a badge. And so I can go ahead and grab a badge here, and let's drag that in. And since we're talking about Lightning Web Components today, let's go ahead and say we're going to be teaching HTML. Let's go ahead and make a copy of that badge. We'll make 2 copies, drag that over. We'll say the next thing we're going to be teaching as a skill is JavaScript. And lastly, why not? Let's throw some CSS in there as well. And then they can start building Lightning Web Components in elementary school there. And there, I think that's given us a quick, simple component. We can see the name of the school, get some details, maybe click on the component to open up into the website that they've supplied. So let's go ahead and group this here. We're going to create a group in Sketch, and we're going to just copy this. Let's go ahead and copy that and drag it down. And let's do that one more time. And there you go. We have now a component that will show us the nearest 3 schools to a location. Obviously, there's fake data in here, but I think this gives us a good basis for actually building out our component. And so let's see now what we can do with this. If we go back into our slides, we've now designed our UI. What about the context of that component? What data does the component need to work? Well, it's going to live on a property page. We know that already. And we're really going to need that location, that latitude and that longitude of the component, so that we can identify which schools are the nearest and calculate that distance. How does the user interact with our component? Well, as we've said before, we think they can click on it and navigate to that website. And so they'll be able to get a bit more information about the course. And then what states does it inhabit? So initially, we're just going to display those 3 schools, but we also have to bear in mind what happens if there's no data available. What if there are no schools nearby? How does our component respond? Same thing, what happens if there's an error? How does our component respond? And now, lastly, we need to talk about how we're going to bring that component all together. Now, the composition really brings together the data, the UI, and the context all in one into a nice package, and that really becomes our component. We know that we have Lightning Data Services available to us. We can use Lightning Data Services to get the record and get that property information from our record. We're going to use an Apex to call out to our endpoint for the nearby schools. You can write callouts in JavaScript in your Lightning Web Components, yes, but I prefer to write them in my Apex because then I know where all of my callout execution is happening. And if I'm running a large org, I can always track back to a certain area of our code to identify where the callouts are happening. And we're going to need a remote site setting as well in order to call out to our API. Now, from a UI perspective, we've already identified we need a Lightning card. We're going to use tiles for those details of the schools, and we're going to use Lightning badges to display the skills. We're then going to reference the design system when we need to, in case we need some of the utilities, and then we're going to iterate over that data. Now, we're going to use a feature in HTML called a data set to navigate to the website, but we'll go through that when the time is right. And that gives us all of our UI functionality and features. And then lastly, we need to talk about the context and how the component works together. Well, when the component is inserted into the page, we first then need to go and get that record detail of the property. Once we have that record detail, we can go and run our call out to get the nearby schools. We can then render the data, and then optionally, they can navigate to a school by clicking on the tile. Now, I think that gives us a good basis. We know where our data is coming from, what the data looks like. We know what the component is going to look like. We have an idea where we can go and grab some of those base components to start working with. And we know how our component is going to be orchestrated. Once we've done this exercise, it will make creating our component so much easier and so much faster because we've already questioned the ways that we're going to be building it instead of just getting hands on the keyboard and starting to write code. And now that we've done that, we can go ahead and start building our component. So let's get into our Lightning Web component. We're going to go and navigate into VS Code. And the first thing I want to show you is our local code school search Apex class. I've gone ahead and written this ahead of time so that we can go ahead and focus on our Lightning Web component today. But just so you're aware, what we have here is an Aura-enabled method called getNearbyCodeSchools that takes the parameters of a property latitude and property longitude for us to then append onto our callout URL with our Heroku app here, so that we can get back those nearest 3 properties. Now, you can do this with a named credential, and if you're doing this in production, I would suggest that. But because this is just a demo and there's no authentication on this endpoint, I'm just going to construct it here in our class. Now, you'll notice we're going to pass back that raw JSON response directly to our Lightning Web component instead of parsing it in Apex, because we're going to parse it anyways in our LWC. There's no reason for us to do that twice. So, let's go ahead and create our Lightning Web component. The way we're going to do that is by opening up the command palette, and we can type in create Lightning Web component and use Salesforce TX to create that component for us. We can just give it a name. We're going to call this one Local Code Schools. And press return, and then we can just press return again to confirm that it's going in the LWC path. And like that, you'll see it's created our component for us. Now, the first thing that we need to do is get that record ID from the record page into our component. The way we're going to do that is by using an API decorator. The API decorator allows us to declare a property as public. Now, the Lightning runtime itself knows that when we have a public property of a record ID available on the component, that if it's on a record page, to pass that record ID into the component. And so we're going to go ahead and just specify the API decorator and say record ID. And there we have our public property. So now, how can we use our record ID? Well, we want to call some sort of mechanism to get that property latitude and longitude from our property record. And we're going to do that by using the getRecordWire adapter that uses Lightning Data Services to call the UI API and get some fields that we specify. Now, the way we do that is we're going to import the wire decorator, and then we're going to just say @wire, and then our method name of getRecord. And then we can pass that some parameters. In there, we're just going to pass it the record ID. And there, we then want to specify a $sign and then our property name of record ID. And that will enable the property as reactive, so that when that record ID changes, it will run this call out through the wire adapter to go and get the necessary data. We then also want to pass it a second parameter, and that is fields. We want to be able to specify which fields we're getting on return of this callout. And so we can do that by actually going ahead and just pasting this in here. We're going to define a property outside of our default class called fields, and we're going to specify that property _c dot our latitude and our longitude. You'll see we've got the _s at the end of the field to show and designate that it is part of a compound location field that we can get the latitude and longitude from. And so we now have our get record, and we're passing in our record ID and then our fields that we've defined a second ago. So now we need to do something with that data. So we're going to go ahead and specify a wired record here. And we're going to pass in here our error and our data. That way, if the response is successful, we'll get our data back. If it's not successful, we'll get an error. So let's go ahead and check that using if statements. We're going to go ahead and just say if data is returned, and we will then say, let's go ahead and define the property. And so we can say property there, our property equals data.fields. And that will give us all of the fields as part of the property that's been returned into our property. Next, we want to then specify the latitude and longitude. Now, to do that, we need a property to place those in. And so let's go ahead and say we have our latitude here, and we have our longitude. And then we're going to say this dot latitude equals property dot, and then we can go ahead and type out our location, double underscore latitude, double underscore s, and then once again this dot longitude. And you'll see I'm using tab 9 within VS Code as a plugin that will auto-populate based on some of the fields and some of the previous things that I've typed in, which is very useful, but always verify when you press return that it's what you expected, because sometimes it mixes things up until it learns your coding style. Now, after that, we want to go ahead and catch any errors. And so we can say else if error, and then we can just say property equals error message. And so let's add in a property for that. And so let's say we've got our error handling here. Let's say, there we go, error message. And let's let error message, this dot error message equals, and we'll say error dot message. And that will give us back the string of the error response that's been returned. And so we can use that to display to our users later on. Okay, and there we go. We now have our wire here. We have our wired schools there. Let's make sure that that's correct. Okay, so you've got an error here. Great. And so now let's go ahead and write our next function to go ahead and get those property details. So we're going to use a wire again, but first we actually need to import our Apex method into our Lightning Web Component. We're going to go ahead and just say import get nearby schools, code schools. We're going to then say from, and then our at Salesforce dash Apex / local code schools, and get nearby code schools. You'll see it's auto-populated that for me. And that's going to go ahead and bring in our Apex method for use within wire adapter. Now we're going to go ahead and specify once again at wire, and then here we're going to say once again, now we're going to specify get nearby code schools there, and we're going to pass in our parameters here. And so let's go ahead and say comma, curly bracket, and let's say our property latitude there, and then we'll say that equals, so again, $, latitude, and then let's add in our next property, let's say property longitude, and once again, it's gone ahead and auto-populated that for us. We can then say wired schools, and then let's pass in our error and our data. And once again, if data, then let's go ahead and store our schools in a property. Let's go ahead and name another property for schools. And let's say schools equals. Now, if we were parsing the data or bringing back data from Apex, we could just say schools equals data, but because we're passing back that raw JSON response from the API, we can go ahead and just parse that here. And we can say JSON.parse, then data. And that will populate our schools property with that data in the structure that we need for our front end. Now, once again, we can say else if error, this dot error message equals error dot message, and there we go. Like that, we've created two callouts really. One to go and get that property latitude and longitude based on the record ID that's been populated, and the second to go out and get the nearest 3 schools based on that property latitude and longitude changing. Now you'll see, because we've specified this $sign in the property name, it's reactive. So based on getting this record ID into the record here, it will go out and run the get records wire adapter. Then once that latitude and longitude are populated, it will go and run the get nearby code schools method to go and get those nearby schools. So now that that's been completed, we can go ahead and jump into our HTML. Now, to save us time here, I'm going to go ahead and paste in a version of this component that I wrote earlier today for us to take a look at. We can see which base components we've selected to use and how we're iterating over that data to give us that component that we designed earlier. Now, if we take a look at this, you can see initially the very first thing that we have declared is a lightning card, because that's the outside container of our component. If we go reference what that looks like in Sketch, you can see here we have that outer card. Then we want to then identify each of the tiles that can exist within that. So here, as I said, we have our lightning card. We can then say template if true schools and verify that that data has been populated. If that parameter doesn't have any data, we don't want to try and hydrate the user interface yet, because that could cause some errors when we're trying to display and render data that's non-existent. That way, if we're checking that that data exists, we're not going to make any of those mistakes. Next, you can see we have a list that we've pulled from the Lightning design system. So we've got a list that has dividers and space to allow us to use one of those utilities to avoid having to pad out the cards and worry about the spacing ourselves. It just makes life much easier when it comes to actually padding out the component. Next, we want to iterate over those schools, and you can just see that we're using a for each iterator here. For item, we're specifying as a school, and what that does is it gives us a variable to use for each of the items within the iteration, and then we're specifying the index for us to use in our key. So for example, inside of each iteration, we have a list item that uses the specification based on this has dividers around space class. It then specifies the key here of school.I, and inside of that list item we have our lightning tile. Now the lightning tile gives us everything that we need to render the tile in the way that we just designed within Sketch. You can see here we're specifying a label, we've specified an on-click function here, and we specified a dataset URL here. We'll get to that in a minute and talk about how we can use that to navigate to these records. Now inside of the tile you can see here that we just have another list here where we're taking the distance and then specifying the distance here, populating that in with the school.distance. Same thing with our description, with our levels. Now when it comes to the levels are actually brought back to us in a list because you can have multiple different school types based on that school. You can have elementary courses, high school courses, college courses, etc. And the way we actually want to render those is reliant on the Lightning design system. If you ever have to render data in a list, always go and check out the list utilities that exist here. So for example, we're going to talk about a horizontal list. We can go ahead and search for horizontal list here, and we can see all of the shortcuts and classes that we can use to create those lists. In this example, I really like using a list that's spaced with dots. And so you can see here we've got those bullet points here in between each item. And so what we can do is actually take that markup and bring that into our component to create that list. And here you can see inside of our code, we have our template iterator here, where we're iterating over that school.levels field, and then taking a look at that item, and then just displaying that value. And like I said, you can see here, we've got that list item detail, we have our dividers left here, and our list horizontal for displaying that data. Now, the last aspect of our tile is those languages and those skills that they offer for their courses. Here you can see, once again, we're going to be iterating over now, this time, the schools.languages array, and specify language as the item itself. We're then taking our Lightning badge component, we're just applying that label here as the language and generating our badge. And that should loop through all of the different languages and create a badge for each language. Now, lastly, you'll see here in the footer here, we've just put a notice to say that the data's come from the code.org local schools database, because that's what they ask for within their service. Please note, if you're bringing in any data from external services, make sure you check out the terms and conditions, especially if it's public data, to make sure that you're giving them the proper credit for their data source. Now, the last thing I want to touch on this, as I mentioned earlier, is using that dataset capability to navigate to a school. What we want to do is enable this tile to navigate to that school's website when it's clicked. You can see here we've specified a data-URL. That data URL will allow you to go to the school's website when you click on the component. What that does is it specifies an attribute as part of this div here that we can go ahead and grab. So now if we pop into our JavaScript, we're going to go ahead and handle that on click. And so what you can see here is we then have inside of our tile our navigate to URL function. We can pass in an event. Okay. In that event, we can access that data-URL by using, like I said a second ago, what's called the dataset function. And so we can say URL equals event.currentTarget.dataset. That's what represents that data dash, and then the name of our dataset property, and that's URL. And that should give us that URL. Now from there, we're actually going to use Lightning navigation services to navigate to an external URL. Now in order to do that, we have to import the navigation mixin up here into our component. We then have to allow our component to extend that navigation mixin. This is a step that I always forget every time I'm writing a component. I can't tell you the number of times that I've questioned why my component wasn't navigating somewhere, and it's always because I forget to do that. And then we can go ahead and bring in that Lightning navigation service function into our method here. And we can say const URL equals, once again, our URL, this.navigationMixin.navigate, and then navigate to a page reference. And in this instance, our page reference is a standard web page, and our attributes are this URL. And that will let us navigate to that URL from our component. So the last thing we need to do before we can actually test this out is to open up our component's configuration file. We need to expose this component, and we do that by setting isExposed to true. We then need to set our component's targets, and our targets in this case are just a Lightning record page, because we only want this to be available on record pages, not home pages or app builder pages or community pages, only record pages. And then we can specify the target configurations to let us know, okay, if it's a record page, what objects can it be visible on? And so in this instance, we've set the object as a property. So we're going to go ahead and save this component and push that to Salesforce. Okay, and save that, and save that. So let's go ahead and see what this looks like. So we're going to go ahead and go into our Dreamhouse app. Great, so now back in our property record, we're going to go ahead and just edit this page here. And let's see if our component's available for us to drag on there. So as we scroll down, you can see here we have our local code schools component. So great, it's come through into the Lightning App Builder. So let's go ahead and drag that onto the page. Here you can see, even in the preview mode, it's called out to the API and returned those schools. So let's go ahead and save this. And let's go back. And that's brilliant. You can see here we have our schools that have come through via the call out. Let's go ahead and let's look at another property and see what happens. Let's look at the heart of Harvard Square. You can see here, once again, we have our schools that have come through with our languages. I really love the badges here in this use case. You can see when I click on it as well, it will take us to that page that's available. So again, click on Harvard University, and we can see it's going to pass us to those pages. It looks like, though, code.org need to update some of their URLs. So if we take a look at Sketch, let's see what the difference is. I mean, and it looks great. We've got our components, we've got the style exactly as we depicted. You can see here we have our card that's come through, each of our tiles, each of our languages coming through as badges. And because we've been able to tie these back to those base components, it's made it super easy to ensure that the style is what we meant it to be when we're deploying it live. And so you can see here our component reflects that. Now, if we wanted to take this to the next level, we can actually start to look at some Lightning Web Component design patterns for bringing in a bit more responsiveness, state management, and look and feel to the component. The first one, for example, is loading. You will have noticed the component itself started out really small and then just jumped to a larger size when the data was available. We can get around this by putting in a proper loading pattern so that we know the size of the component generally will be able to fit a certain shape, show a spinner, and then allow us to hide that spinner when the data has been received. We can use a pattern like a stop loading function with a set timeout that allows us to ensure that we're not getting little flashes of spinners, but that we've got a consistent spinner and loading time for each of our components. Another pattern we can rely on is an empty state. It's part of Lightning Design System. They provide loads of illustrations that we can use to display an empty state component. You'll notice here we're using the LWC messaging utility, which is actually a Salesforce Labs app that you can use to quickly show illustrations and messages. Once again, we're doing the same thing with our error handling. We're using that messaging utility to just pass in the parameters from the component that show us that error message. Now, if you want to take a look at that, it's actually a Salesforce Labs app that I've built. You can go ahead, download it. You can get the source code on GitHub and include it in your projects for a quick and easy way to show the different types of error messages that exist within Salesforce and are designed by the Lightning Design System team. So let's take a look back at our code and let's implement a couple of those patterns. I'm going to go ahead and replace this code with one that I've written earlier that brings these patterns in. Here you can see initially I've got my stop loading function as well here that will go ahead and stop the loading of that component. And you can see at each of our functions here that are getting called by our wire, we have a stop loading every time there's an error. And if the data has been then received, we have a stop loading so that we know to render something within the component. If we take a look at our HTML, we can go ahead and grab that. And let's drop that back into the page. And you can see here we have quite a few conditional statements here around our templates, around loading. So if loading is true, let's show the spinner. See, if loading is false, we can then start showing some of our content. We can say if there's an error, let's pass back to our messaging utility and pass the error context. Same thing with the schools. If schools are false, let's go ahead and pass in an illustration. You can see here I said we've specified an illustration as the messaging type and the name of that illustration. Now lastly, let's go ahead and create a CSS file here to give our spinner a container. And so we're going to call that local code schools.css. Okay, and in that we're going to go ahead and paste in the CSS of our spinner container here. This is just taken directly from the component library. We're going to go ahead and save that. Let's save our HTML and let's save our JavaScript. And let's go ahead and refresh our page on our component and see how it's responded. So once again, we're on the heart of Harvard. Let's go ahead and refresh this page. And here you can see we have a proper loader that's spinning the component before we see our component. Once again, if we navigate to another page, City Living, you can see it's going and getting the data, allowing the user to identify that it's currently loading and then showing us the data instead of just instantly trying to hydrate a component that's empty. Now, like that, we found a great Lightning Web Component use case in Dreamhouse for creating those nearby properties and getting that data. We've designed our component by looking at the data set, how we can get the data. We've taken a look at how we can use some user interface patterns to really design our component before we start writing code to ensure that our end result is going to be what our users expect and find useful. We've then taken that and put it all together within the context and composition of the component to really understand how those pieces of the puzzle interact with each other. We've then taken a look at some design patterns and enhanced our component by bringing in an empty state manager, a loading manager, and things like error handling. And in the end of the day, we've delivered some really good value to our users in minimal time because we've put that effort into the upfront design. Now, thank you very much for attending my session today. If you have any questions or follow-up, please reach out to me using the contact information we specified earlier. If you'd like to reach out, please do. I'm happy to answer your questions, and I think it'd be great. So, on that note, thank you very much, and have a good rest of the day.